guys, we are on lesson 3, numbers in exponential form raised to a power. It's on page 23. And you're starting off by looking at the power rule. It's in a box. And it says for any number x and y and any positive integers m and n, x to the m power raised to the n power is equal to x to the n times m. And this explains it a little bit further, though it's a little complex in nature because it's hard to show unless you have very low exponents. For example, and I apologize, I had done this all on video, but the video didn't upload, so being flexible, right? That's the word of the year. So anyway, for exercise 1, and I'll explain them, and you can fast forward if you already get them, you have 15 raised to 3 raised to the 9. So that quantity there is raised to the 9th power. And that's going to be equal to 15 to the 27th power because you're multiplying 3 times 9 power by power. And that's what this is called, the power rule. And that so it's 15 to the 27th. How I could show that is that 15 raised to the 3rd power is 15 times 15 times 15. And I would do that 9 times here, right? That's what this all is showing. I would do all of that 9 times. And so what I would end up having is 15 multiplied by itself 27 times. Okay? And so that kind of shows it. And then you see the solutions here. They're just simplified. You could go further, like negative 2 raised to the 5 times 8 is negative 2 to the 40th. Right? So you could check your work here. You can pause the video if you need to. For exercise 5, Sarah did this problem here, and she did it incorrectly. She did the product rule, not the power rule, is what that says there. You can pause and copy this down if you'd like. So what the correct answer would be is this. It would be 3 to the 35th, which is 3 to the 5 times 7. For her particular mistake, she would have been correct if it was 3 to the 5th times 3 to the 7th. Then she would use the product rule. And then exercise 6 is really complex. If you want to copy it down, you can. Otherwise, just skip it. Okay, and on the back, now we're back to live video. You guys have the expanded power rule. It's the one on the box, and this is page 24. And for the expanded power rule, for any numbers x and y and positive integer n, you have x times y raised to the n is equal to x to the n times y to the n. So we have multiple bases in there, and each one is going to receive the exponent. That's what the expanded power rule is. Okay, and this kind of shows why that would be the case and why this would work. I could show that here, possibly. That's a little large, though. Okay, so for this particular problem, and it might even be helpful to do some of these with you because the example might not show everything well enough because it's just variables. But for exercise 7, so you have 11 raised to the 9th power, and if there was an exponent here, which there is, it's just a 1, 11 raised to the 1 power, you'd have 11 raised to the 9 times 1 power, right? 9 times 1. Likewise, so multiplied by 4 raised, and there would be a 1 here, raised to the 9 times 1. I just want to show you that just because as we go, that might make more sense to show it for each one. So then this would be equal to 11 raised to the 9th times 4 raised to the 9th. Okay, for exercise 8, you do have exponents inside your parentheses and outside your parentheses as well. So you'll see why I did that here. So you have 3 to the second power times 5, so it's 3 to the 2 times 5, right? Times, and we go to the next base, which is 7 to the 4 times 5. Okay, and those could be in either order, the multiplication. Okay, and I could simplify further, but really I don't need to for this particular lesson. It's just learning how to use the expanded power rule. And exercise 9, A, B, and C are numbers. And so for this particular one, you have 3 to the 2 times 5 times A to the 4 times 5. And for 10, you have 5 to the 7 times 1, right? We're just saying that there's something there, and then x to the 7 times 1. And 11, 5 to the 7 times 1 times x to the 7 times 1 times y to the 7 times 2. And same thing as I've been saying here, you could have 5 to the, well, you don't even need the 1 there, but you could have for this one y to the 2 times 7 as the exponent. Doesn't matter the order. Okay, exercise 12. Looks like it's getting longer. So we have a to the 2 times 4 times b to the 1 times 4 times c to the 3 times 4. Okay, and then for exercise 13, which is the last one, it says let x and y be numbers. Y doesn't equal 0, and let n be a positive integer. And if y was 0, this wouldn't work, so that's why they're saying that. Same thing as if it was negative, it wouldn't quite work, so that's why that's stated. How is x to the divided by y raised to the n power related to x to the n times y to the n power? So you might want to pause the video and see if you could figure it out, and then we could keep going. So really, if you have this, so if we break it down, I'm going to just break it down here. You have x divided by y raised to the n power is equal to x divided by y times x divided by y times dot 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 x divided by y, and this is happening n times so that all is happening n times with, and if I break that down, the x times x times x is happening n times, and we're dividing by the y times y, dots in there, times y, dot, 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 and that is happening n times. Then we have x to the n, so x to the n and y divided by y to the n. That's how it's related to x to the n and y to the n. Is that power, that the exponents on the outside will go to the top of the division problem here and the bottom. So it goes to the entire quotient, and that is why. Okay, at this point, you're going to skip the exit ticket again. Oops. You can check out the homework helper, and then the problem set should be on assessments in Google Classroom. All right, guys, bye.